Welcome to this video on Gnip's Historical PowerTrack API. During this video, we'll be discussing key concepts of the Historical PowerTrack product, including the historical job life cycle. We'll be exercising that complete life cycle using the API to generate a data set, and then we'll also talk about important API details. Before we get started into this material, please remember that all of our documentation is hosted at support.gnip.com. I'll start off by discussing some key concepts related to the Historical PowerTrack API. The first is that historical jobs are the main entity of focus. A job description specifies a single period of interest and includes up to 1,000 rules or filters. A RESTful API is then used to create jobs and marshal those jobs through their life cycle. Filters are written with standard PowerTrack syntax, and the end product is a set of 10-minute data files that you will download. When you are provided access to the Historical PowerTrack API, you will be provisioned a URL endpoint that will represent the endpoint with which you make all API requests. For this video, I am using an account called Gnip-Learning, and that is encapsulated in my example URL here. Another key concept is when jobs are created, they are assigned a universally unique ID, or UUID for short. And then all API requests reference that UUID to move that job through the process of generating data. Another fundamental thing to keep in mind with the Historical PowerTrack API is that all times are in the UTC time zone. Now, this is true of all the APIs that Gnip provides. With respect to the Historical PowerTrack API, this includes the from date and the to date parameters that are used to specify the period of time that you're interested in. It also includes all timestamps that make up parts of the data file names, as well as all timestamps in the data payloads that are delivered through the API. So now we're going to make our first request to the Historical PowerTrack API. And what we are going to request is a job list. We're going to get a list of all of the active jobs associated with this account. And again, for this video, we are using an account called Gnip-Learning. So this will give us a list of jobs that perhaps are being estimated, perhaps jobs that have been estimated but not accepted yet. It'll also show us any jobs that are currently running, and it'll show us all completed jobs for the last 15 days. Now, to get a job list, it's as simple as making a GET request to your Historical PowerTrack endpoint. So here I have a curl command which represents that. Keep in mind with curl that the GET method is the default, but I'm explicitly showing it here just for illustrative purposes. But I'm doing a GET command to the endpoint that you see there, which again encapsulates my account name and ends in jobs.json. And I will be specifying my username and password. So now we're going to go see the results of that type of request. So here I am using terminal. I have copied in my curl command, and I'm going to authenticate. And you'll see that the server responds with a JSON body showing me what jobs are currently active on my account. To make it easier to read, I'm going to redo that command but pipe the results to JQ and basically pre-print the JSON. So there you can see this is a brand new account. I have only ran one job on this account, and so here you have under the jobs attribute an array, in this case of just one job, and then at the bottom is the month to date totals. I ran one job. That one job returned nearly 15,000 activities, and it tells me that this is my account usage since the start of the month. As mentioned, the main object that this Historical PowerTrack API works with is what we call an Historical PowerTrack job. And every job has a life cycle that the API is used to move that job through the various steps needed to create a data set. We will talk about all of these steps in detail, but the first step is creating a job itself. That is a definition of the time period you want to pull data from. It's also the specification of what filters you want to apply to the archive of Twitter data. The second step is you'll receive a job estimate, and then based upon that estimate you can decide to accept or reject the job. If you accept the job, that's where we kick off the heavy lifting of moving through the Twitter archive and pulling all tweets that match one or more of your filters. And while that process is running, you can use the API to monitor the process of the job. Is the job 50% done? Is it 75% done? And then finally to confirm that the job is complete. And then the final step of this life cycle is the actual downloading of the data. So let's talk about these steps in detail. And again, the first one, of course, is creating a job. Every time you create a job, you will be assembling and creating a JSON object which describes that job. And that JSON object will have the following attributes. First, it will have a title, and this is used as the job list index. So these titles must be unique since they are used as the key. Next, you will define the time period that you're looking to pull data from, and that's defined with the from date and a to date parameter. And keep in mind the format for these parameters are shown here at the bottom. It's year, month, day, hour, and minute. There is also in the job description a rules attribute, and that rules attribute has a value which is a JSON array of up to 1,000 rules or filters. And for each rule and filter you will have a value attribute and also an optional tag attribute. And in a minute we'll show you a complete JSON object that shows these details. Also, you have a choice of data format. We support 2 formats with all of these products, including the Historical PowerTrack API, and that includes the original format, so that would be the format as delivered from the public Twitter API. So if you've ever consumed data from the public API, it'd be the same format as that. And the alternative is the activity stream format, and that's a format that you'll need to use if you are interested in any of the Gnip enrichments, and for that reason it is by far the most widely used format. The next 2 attributes, publisher and stream type, are static. They will always be set to these values. So if you're writing code, you can set these to these default values, where publisher is set to Twitter and stream type is set to track. So now we are going to create a new job. And the way you do that is you make a post request to your Historical PowerTrack endpoint. Again, I have a sample curl command here. Notice that the method I'm using is post. I'm not doing a get. I am going to the same historical endpoint that I used previously, but in this case I will be posting a data body. In this case I'm referencing a local file that contains the definition, the JSON object that defines my job. I will make a post to my endpoint, and that will hopefully create me a new job. So now we're going to take the next step of creating a new job, and here are the contents of my job definition file. You see here the attributes for this JSON object which will define my new job. It has a new unique title. I'm now looking at the second 12 hours from this flood event. You'll see that my from and to dates start at noon UTC on the 12th and end at midnight on the 13th. Keep in mind that the from date is inclusive, so I will get all tweets in that first minute of noon UTC, and the to date is exclusive, so I'll get every tweet up to midnight, so 11:59 and 59 seconds. You'll also see this rules array. The rules attribute points to a JSON array of one or more PowerTrack rules. And again, you can have up to 1,000 of these. In my case, I have 7. I'm mainly looking for keywords associated with floods and rain and storms, but coming from Twitter accounts that indicate they are in Colorado. I'm also looking for certain hashtags that were popular during the flood. I'm also looking for tweets that came out from our local agencies, for example. And with these rules, you'll see that I'm using rule tags. Now, rule tags, I won't go into great detail here, but in this case, I'm using them to segregate and to label basically my rules and indicate the characteristic of that rule. For example, that first one, I'm looking for flood keywords that are also associated with a profile geo of interest. So this is the job that I'm going to create with the API, and we'll do that next. So now I'm going to post the contents of that file to my endpoint using the post command, authenticate, and we'll see here that I received a 201 response code, which is a sign of success. And also the server, the API, responded with a JSON body that echoes the type of job that I just created, and also has a job URL, which points me to the UUID that's been associated with this job. Here's a better look at the JSON response that the API provided when I successfully created a job. Now keep in mind I received a response code of 201, and again that is what you're looking for. And that means several things. One, my JSON was put together in a valid fashion, that my rules didn't contain any strange syntax errors, etc. So if you're getting a non-201 response, you will also receive a non-201 error code, and with that you'll have an error message that you should certainly parse and log, and it will point you to the problem. So here's the JSON that the server responded with. Again, it's basically repeating the parameters that I passed in. However, you'll notice towards the bottom after the toDate attribute that it tells me the user email of the account that was used to create the job, what time the job was created, and again, that's UTC. It tells me that the status of this job is now opened. Also, it gives me a status message telling me that Gnip is busy generating an estimate. And very importantly is that job URL. So that'll be a URL that you will interact with directly to marshal this job through the process. And an important thing for you to do with this URL is to parse out that job UUID, and you will use that in subsequent requests to the API. And so now that the job has been successfully submitted and created, the next step is to get the estimate around the job. And in this case, you'll be making a GET request to the job URL. So not your root historical endpoint, but the job URL that specifies the particular job you want to work with. So when you do that, you'll get, as part of the response from the server, you'll get a quote object, and it includes these attributes which make up the estimate. The first is an estimate of how many tweets we think will be associated with your filters for the time period you specified. And this is a ballpark number. Usually it's pretty accurate. I'd say within 10% typically. Also, it includes the amount of time we think it'll take in hours to complete the job. In this case, we came back and gave an estimate of 1 hour. And these estimates are, and the time it takes to generate a data set is mainly driven by the amount of days and the time period you're requesting data from. It has less to do with how many rules you have or how complex they are. The other estimate that we provide is on the payload of the compressed payload of what you'll need to download when it's finished. In this case, this estimate's for only 2 megabytes of data. And the final part of the estimate is the time at which the quote expires. So you are given a week to decide whether you want to accept or reject the job. So here I'm going to retrieve the estimate for this new job. And again, I'm referencing the job URL. And I'm piping it the JQ again so the JSON is formatted in a nice way. So there in the quote object towards the bottom, I have this quote for this new job. And in this case, the estimated amount of tweets is 44,000. And again, it appears that it'll take roughly an hour to generate that data. And the file size of the compressed payload to download will be just over 21 megabytes. Based on these estimates, you can decide whether to accept or reject the job. And these different attributes should all be considered carefully. For example, if the amount of tweets to be delivered is an order of magnitude from what you expected, it gives you an opportunity to revisit your rules and perhaps refine them. Certainly, if the estimated time to complete the job is not going to work for maybe a deadline you have, then you should carefully consider not proceeding with the job. And in that regard, keep in mind that say you're doing a 90-day period of data and you're doing that within one job, and the estimate for the time is longer than you would like. Remember, you have the option to split that job into 3, say, 30-day jobs and run them concurrently. So the next step in the process is to accept or reject the job. In this case, you'll be making a put request to your job URL. And to accept or reject the job, you send a simple JSON object with an attribute called status set to either accept or reject. Here I have an example curl command showing just that, and next we will demonstrate how that works. So now I'm going to go ahead and accept this job. Here I'm doing a put command to my job URL with a request body that says accept. Authenticating. And here I got a response code of 200, meaning everything there went fine. And the API will respond with another JSON response, again showing me the current status of this job. Here is a nicely formatted version of what the API returns when you successfully accept a job. The things to note here is that the status has been updated to accepted. The status message is job accepted and ready to be queued. And also it indicates what account accepted the job and the timestamp of when the job was accepted. So now that we've accepted a job, the next step is that we can monitor the progress of this job. And you do that by, again, doing a simple GET request against that job URL. Now keep in mind that this job is pretty short. It is just a 12-hour period. And although our estimate was 1 hour, it'll likely take much less time than that. So let's go check on the progress of this job. So now we're making a GET request to our job URL endpoint. And we see that it's 95%. Here we're going to make another check on the job and see if it's finished by doing another GET request. And here, in fact, we see that it is 100% complete, that bottom attribute there. And with the completed job, you now get a results object, which is metadata about the completed job itself. In this case, we see that we have 41,921 tweets in our data set. We find out that we have 72 files to download that have an uncompressed size of just over 20 megabytes. It tells us at what time the job finished. In this case, the job only took a few minutes to complete. And very importantly, we have this new data URL attribute. And again, that is a URL that will provide a list of files to download from a remote server. And finally, it tells us that we have until, in this case, May 13th, 2316 UTC to download the data. After that point, the data will be removed from the server. So the data URL is the JSON attribute you will need to download your files. It points you to the list of all the files that make up your data set. Note that we have a separate video dedicated to automating the download process, where we demonstrate a variety of tools to do so. So the file list provided by the data URL is available in two different formats. One format is the JSON format, where you'll find essentially a JSON array of download links, and there's also a CSV version of it as well. And they are delivered through two unique different endpoints. I have them both listed here. You'll see the top one ends in results.json, and that corresponds to retrieving a JSON list. And the second one there ends in results.csv, and that, as the name implies, is a simple delimited text list of files. So you have your choice as to which format you want to work with. I generally recommend the JSON version. Most software languages have full support for JSON, making it easy to parse the JSON and iterate through the file list there as you download each file. On the other hand, perhaps you prefer to work with the other CSV format. In fact, our curl commands and also our bash script operate with the results.csv version. So it's really up to you. So now let's take a look at what's inside this results.json. Here I'm piping it to JQ in order to format the JSON. You're going to see here a long list of files, in this case 72 different files. At the bottom here I have some metadata about the payload itself, the size, and when the payload will expire. I'm going to scroll back up through the contents. At the top you'll see metadata around how many files are being pointed to, and then the array of links. If you look carefully, you'll see that these links are self-authenticating download links for files that are hosted out on Amazon. Let's talk a bit about the file characteristics of the files that you will be downloading. First, again, is that as downloaded, they will be gzip compressed. The tweets in those files are encoded in JSON using the UTF-8 character set. The tweets are written in an atomic fashion and are not contained in a JSON array. In a minute, we'll take a quick tour of a sample file to illustrate that. Also, the files will likely contain blank lines, so as you're developing your parsing code to open these files and parse out the tweets, your code needs to be tolerant of that. And also, each file contains a footer with information about when the file was created and how many tweets are contained in that file. Now that you have downloaded your file set, let's talk about the file names that make up this set of files. You'll notice that the file name starts with the job UUID that was assigned to this particular data set. After that, we have a tokenized date and time, and this date and time represents the starting minute of the tweets that are inside that file. And remember that these are 10-minute files, so each file will contain 10 minutes worth of data. The tokens there are the year, month, day, followed by the hour and the minute. These files will end in activities.json.gz. And again, the GZ just indicates that we are using gzip compression. After you uncompress these files, you'll end up with a JSON file. Now let's take a closer look at these files. Here is an example file from our data set. You'll see that the compressed GZ version is just under 0.5 MB, whereas the uncompressed JSON version is 3 MB. Here I've opened up our example file in a text editor, and you can see that each line contains an individual tweet and that there's one tweet written per line. And notice that these tweets are not contained in a JSON array of tweets. Now let's scroll down through the file. Here you can see there is a blank line embedded in the file. And again, your parsing code as it opens and navigates this file will need to be tolerant of those. And here finally at the bottom is the footer showing us when the file was created and that there are 887 tweets in this file. Now we're going to switch gears and discuss some key characteristics of the Historical PowerTrack API. And these are things that you should consider while you're integrating with this data service. The first is that the number of jobs simultaneously in either the running or estimating stages at any given time cannot exceed 15 jobs. Also, after a job is accepted, it cannot be canceled or stopped and will be counted towards your account. And this, of course, is a great reason why your process should involve some review of the estimate that's provided. Another characteristic is that the time required to process an historical job depends primarily on the length of the time period covered and has much less to do with the number of rules and the amount of data returned. Also, tweet data is available 30 minutes after it is delivered through the fire hose. So approximately 30 minutes after a tweet is posted, it will be available via the historical product. Also, any data can be requested back to the start of the Twitter archive, which is March 21st, 2006. And the time frame for a job, as specified with the to date and the from date, can be specified down to the minute. Another characteristic is that tweets matching more than one rule in a job will be delivered a single time. Note that in the activity stream format, the matching rules array will indicate all matching rules. And also note that if you are using our longer form of rules, the rules that can be 2048 characters long, in those cases we will only return the matching rule tag. Another critical characteristic to keep in mind is that the data is made available for 15 days after the job is accepted, and jobs will not be rerun if the data is not downloaded within 15 days. Another important detail of the Historical PowerTrack product is that data returned from the API will not include deleted tweets or tweets otherwise withheld for compliance reasons, and compliance is valid at the time the data is generated. If you have questions about our compliance API, go to our support.gnip.com website. Also, if you are filtering on Gnip enrichments, the ability to match on that metadata depends on when the enrichment was first introduced. For example, rules with profile geo operators will return no data for periods before August 1st, 2013. We have all the needed information about the start dates of these enrichments on our support site. If you go to support.gnip.com, go to APIs, select the Historical PowerTrack product, go to the overview section, you'll find this anchored section on all of the details. Finally, if you are building an integration with the API, here's a short list of functionality you'll need to include. These are general design goals but should help inform the development efforts necessary. First, you'll need to create a client application that can send HTTP requests to the Historical PowerTrack API that creates and manages jobs. Also, ensure that the client application provides adequate validation on the size and characteristics of the PowerTrack job to prevent unwanted jobs from being accepted and run. And finally, your app should download and be able to store the JSON data delivered via an array of potentially thousands of files. If you're looking for some code examples to help kickstart your integration, be sure to visit our code page for the Historical PowerTrack API. Here we are on support.gnip.com. One way to navigate to the code examples is to select the code main menu option and then select the Historical PowerTrack link. So here you see the different code examples listed. This top one is a Ruby on Rails integration with the Historical PowerTrack API. This next section, as it implies, is a set of very fundamental code examples of showing RESTful requests to create historical jobs. Down here we have another bash script example for downloading Historical PowerTrack datasets. And finally we have example Python and Ruby libraries that can be used to manage Historical PowerTrack jobs. Remember, if you have more questions about the Historical PowerTrack product or any of the other products that Gnip can provide, check out our support site at support.gnip.com. Thanks for watching this video, and be sure to check out our other videos available at support.gnip.com.